Well, hi, good morning. Thanks so much for joining me in my shop here, keeping me company while I work on this Nordmende radio you see here. Today is March 25th, and we're going to start right off with tube testing. Again, I've got a couple of replacement tubes here I need to test. Make sure that they are good before putting them in the radio. The first one is the ECC85 or the North American designation is 6AJ8. So I think I have the tube tester set up. Let me just double check here very quickly so I don't make a mistake. ECH81, EV2613 with a 7. EV2613 with a 7 on the end. And the other two settings are 14 and 70. 14, that one's important. 70, not so important. Here we go. Let's find out if we got a tube here that's worth putting in that radio. So the weather here has gone it's gone crummy, basically. It's kind of another all-day gray day. Rain here and there, maybe even some snow, and it's temperature hovering just above 0. It's very disappointing for my cats. But the good news is yesterday I shoveled all the remaining snow off my deck, so my deck is snow-free, and that means spring is coming, for sure. Okay, any shorts in here? No, this looks like a good tube, judging by how bright these are, which is not the best way to do it. So this tube, I have to look on my chart over here. This tube should come up 1260 at a minimum. So there's where 1260 is. What do we get? Oh, excellent. Okay, fantastic. I think this is a two-parter, so we should probably do the other part, which is 98030. 98030. This goes up to 80, and it's ready to go again. Fantastic. What's that supposed to come up to? I didn't check. It's supposed to come up to 2000. So 2000's up here. Excellent. Okay, we got a good ECH81. Now the other tube I've got here is an EF89. I've got to get my tube tester set up for that. Okay, let's double check these settings. EF89, EV2783. EV2783 with a 9 on the end. 23 and 73. 23, 73. We're good. Let's see if the tube is good. So this tube is supposed to come up to 1320. If it doesn't get over 1320, time for a new tube, according to the chart. But I find, in most cases these tubes are serviceable below those numbers. Okay, here we go. Shorts. Okay. That's sinking. So the pointers come up, and now it's sinking. And I think that's an indication this tube is near the end of its life. How many hours are left in it? Who knows? And is this going to help the radio? Probably yes. The actual numbers, let me double check here. EF89, 1320. 2000 would be a good one, way up here. So it is actually, back in the day, it'd be time for a new tube. But we're gonna take a run with this one. Well, it'd be interesting to see if the radio will actually work with it. Okay. Now, one of the things I'm really good at is getting the tubes mixed up. So if I have a really bad tube, that's this one. To make sure it doesn't get mixed up, I bend one pin a little bit. And I know it's me who did that. Now I can't mix this tube up. Mistake it for a good one, because I have a lot of skill in that respect of mixing these up. Okay, we'll put this one in. I can't remember how bad this one was. Let's retest this. I don't remember. I mean, it was all the way yesterday. And this is all set up for it. So. Okay, running the risk of mixing them up here. Oh, this had a short in it, I believe. Let's see if it shows up again. There's a short on the other tester. There's a short reported on the other tester. What's this guy say? He says it's a pretty dead tube. I'm watching the short light. Normally a good tube tends to flash the short light when you're swinging the control. So it's not really showing a short. And if we do the T4 thing, oh. Yeah. This is as cold as can be. Looking to see if the heater's coming on. Let's watch the pilot light here. Seems to flicker just a wee bit. Yeah, I think this guy qualifies as a doesn't work. He gets a bent pin. Okay, we'll put this guy in. I have an exciting time now, seeing if this radio will come to life. This really might be just about all this radio really needs. It's just some refreshed tubes. Okay, we'll put it in. Of course, you could ask yourself, well, what's killing these tubes? Right near this tube is one of those bad capacitors. I don't think it's too likely that was the cause of a tube death. But who knows? It's hard to explain. It's like a chain. You pull on a chain too hard, all the links don't break, just one link breaks. So how do you end up with a multiple dead tubes? This one is weak also, but it's probably good enough to get this radio off the ground. And what we're really curious about is this output tube. This is a very expensive tube. ECLL800. Very expensive tube. But I've located one. One of my friends has one. An NOS tube, so that's good. My normal tube supplier, which is a company in Hamilton, Ontario called the Tube Store, they don't have them in stock. I think these are pretty scarce tubes. Okay, so hopefully this one will work. Okay, have I delayed long enough? Are we all set here? Volume down. That's a hopeful sign, turning down the volume. And we have nothing turned on. Going through the dim bulbs on the broadcast. There we go. So you missed it, but the bulbs brightened up and went down right away. You might have heard my phone bing in the background. Here comes the magic eye. Okay, we'll go on full. Oh, the eye is a-moving. The eye is a-moving. Come on. It's not quite what you want to hear. It's a little better. Well, it's working. It's a radio! Now the pointer is just totally out of whack here. It's all that clicky noise. Not sure what all that is. So that rumbly, actually you can't even distinguish it there, so I won't talk about it. All the way to the end. Okay, we've reached the end. I can see a little divot in the string, which probably marks where the pointer used to be. So the pointer used to be right near the spring here. Hey, what's this? It's going in and out. What's that? The volume turned up quite high. fact, it's full. Push button problems? Doesn't seem like it. Seem to be fading out. Like the volume's gone even down. Okay, so I think this is an overload on my LED lights here. Oh, that's just me stepping in front of it. Yes, I turned my lights down slightly and that's gone. Almost gone. Good. It's just moved. Well, it's not picking anything up. It's quite possible it's the angle of the radio. Let's re-angle it here. It's a little precarious. I got a lot on my... The other day, my wife realized I'm using this, and I've been using this for years. But she realized, hey, that's it. I want that back. You notice it's still here? She's not going to get that back. Well, so it's picking up stuff. Just that's nothing you want to hear. Okay, let's get to FM. Here we go. Oh boy, I gotta turn the volume right up full. Has its antenna plugged in. Wow. Yeah. So that was the police. Let me tell you a little story here. Back just after I met my wife, when I was in college, we lived in downtown Toronto. We were going to a school called Ryerson. We lived in a student residence, a co-op residence called Neil Wysick. And we were going to walk down to the main street in Toronto called Yonge Street, just 2 blocks away. We came out of our apartment building there and we're just walking together down the street, and we passed this small cafe called Edgerton's. So Edgerton is the first name of Edgerton Ryerson, a political figure in Ontario's history. It had something to do with the school system. That's why Ryerson's called Ryerson. It was Ryerson Polytechnic Institute when I went there, but now it's Ryerson University. Anyways, we're walking down the street. We passed this little coffee shop. Maybe it's might have been, I don't know, it was around noon or 1 o'clock in the afternoon. And they often had small musical performers in there performing. You could hear some music coming out, and I just stopped with my wife for a moment. I've never done this before. Never done it since. We just stopped, listened for a moment. I said, you know what? Let's go in there. This sounds really interesting. Let's go in there. And then we looked at each other and it's not what we do. And we're on our way, downtown. So we carried on walking. If we'd gone in there, we would have seen the police doing their first performance in North America. Duh. So instead of telling you a great story about how we watched the police in their first performance in North America, I have to tell you we walked by the police doing their first performance. But I did hear a little bit of music coming out, and it caught my attention, interestingly enough. Yeah, if only I'd known, right? How many things in life are like that? Well, here's the situation. Reception poor. Maybe if I change this too, we might see a big improvement here on the FM side. Volume very low. It implicates the output too, but we can't be sure of anything. Well, that's a little bit of a disappointing result. I'm going to look for another ECC. Was it ECC85? ECC something, and or 6AQ8 or something like that. Tube to go in here, see if we can't get a better response out of the FM side of this radio. Yeah, that's too bad. I was really hoping for full strength operation. Okay, but We're not at the end of the road by any means. Maybe I'm going to travel down memory road for a little bit. So I mentioned the apartment building that my wife and I lived in with the housing co-op. This is it. This picture was taken in, I gotta guess, 1978. And that shows a 22-story apartment building full of 700 students living in there. It was a housing co-op. It was a real co-op, and it was run by the students who lived there, including me. And I lived on the 14th floor, and I also lived on the 22nd floor, way up here. I've mentioned this before. I never pulled out this picture, I don't think, because at one point I had an antenna on the roof of this building, a big folded dipole antenna going across the roof, and the lead came over the top edge of the building, down a couple stories and into my window. Can you believe I got away with that? And it was hooked up to my big Hammerland shortwave antenna. Yeah, housing co-op. I eventually became the president of that co-op. I'm kind of proud of that. Kind of distracted me from school, though, I have to admit. So unfortunately, this building down here is gone. There's another apartment building that was built right up next to this one. This mural, which was quite well known in Toronto at the time, got covered and disappeared. And Edgerton's, you can just see it right here. This is the roof of the Edgerton's Cafe, and we came out of the door down here behind the radio and just walked this way. That's my story. So that's at Church and Gerrard Streets. Actually, Mutual Street. If you know Toronto, this is Mutual Street down here, and this is Gerrard Street across the front. And the school I went to was right across the street from there. So yeah, that building is still there. It's still a housing co-op, as far as I know. It's still called Neil Wysick, and still run by the students who live in it. I mean, that's hard to believe, isn't it? We were 17, 18, 19, 20 years old. There were a couple of people who lived who were a little older than that. 700 students, totally mixed, totally integrated, male, female. There was no attempt to separate male and female at all. And no adult supervision at all. Nothing whatsoever. It was not owned by the school. It was completely independently owned by the housing co-op corporation, the co-op corporation. So there we go. Housing co-ops. Housing co-ops are the solution to housing crises and issues. I won't go into it, but too bad that the co-op movement still exists. There are still co-ops around, and that it never ever exploded into what it really should have become, I think. So there we go. Neil Wysick. Yeah. Anybody remember that place? Oh, I got two 6AQ8s in the box here. These are probably NOS, new old stock, which means they're old in terms of when they were manufactured, but new in terms of them never being used. That's his 6BZ7. That happens. 6BZ7. Now, is that a possible replacement? There's a long list on one of the websites for replacing this ECC85. Let's see what this one says. 6LT8. It's nothing to do with what's written on the box. That happens all the time, and as part of my tube collection, I have not gone through all the boxes and identified all the tubes properly. Let's take a look at that list, because I think 6BZ7 was on the list. It was a long list. Surprisingly long list. So I'm on a very, very helpful website called Nostalgia Air, and this is their tube area, and you just click tubes up here at the top. Enter the tube you're interested in, and one of the things it gives you right away are all these replacements. Look at them all. The only one I'm actually familiar with is the 6AQ8, the one I'm trying to find. But look at the long list here now. 6BZ7. 6B, there it is, 6BZ7. a possible replacement. I'm going to look into this a little bit further. And they're suggesting the base diagram is the same for all these tubes, but can they really be that similar? And 6BZ7, well, heater current down here. So on the ECC85, the heater current is 435 milliamps. I guess I could just click here and shoot to that tube. Does it reverse list it? See, it does not list this. Ignore all these asterisks here. It does not list it. Okay, at a glance, looks like the same diagram. 0.4 amps, about the same current. You just pop it in there? I'm not sure of that. Once again, like, they don't reverse list it here. Let's just take a shot at a tool and just do this. We'll just go into ask, hey, Mr. Google, if I had an ECC85, what would a substitute be? Yeah, see, this is the usual one they talk about, 6AQ8. Okay, we'll go to Radio Museum and see what they list. So, see, they just list this one. They don't even list it as a similar tube. Yeah, I'm going to stop for a bit and do a little research on this before I stick one of these tubes in. So much for me having the 6AQ8. Okay, well, one of the things I don't like about researching stuff like this is I find out how little I actually know. It's really upsetting. So 6BZ7 and a whole pile of similar tubes. They're all very, very similar, and can generally be swapped around, so it seems, without too much risk. Each one had a little bit of a different operation, but same pinout, same basic voltages, same basic job. They're all dual triodes. Is there any risk in sticking this in there? I don't think so. I don't think there's much risk at all. This is looks like a NOS tube to begin with. Let's give it a try. We'll see what happens here. We'll see what happens. I guess, we live in a world now where these tubes are all becoming somewhat scarce. Not the BZ, I got a ton of those, and BQ, I got a whole bunch of those. So this is good news if these can just be plugged in and maybe suffer a small performance loss of some sort. Okay, so we're going to start her up on FM, and I'm going to use the dim bulbs to reduce the supply voltage a wee bit. Boom. Nope, no boom. No, it's heating up. First time you've been on the earth, you've been on the planet for how long? This is the first time you felt the warmth of your own heater since you were in the factory. That's my guess. Now, one of the things we're trying to figure out here is this tube weak, the output tube. Not going so well. Well, that didn't work out very well. I think I read a comment by somebody about they could get the set to operate if they injected the signal right into the grid of the tube as opposed to coming in through the antenna. But it came in through the antenna, they didn't get anything. Okay, I'm not getting anything. Okay, that didn't work out. Of course, I got it on low voltage. How low? 94. Okay, let's give it the works. Give it the works. Oh, there we are. It's about the same though, volume-wise. Let's see what we get for tuning stuff. Well, I'll be. Oh, and that's the sound of my alarm telling me I have to go to the grocery store now. Well, it's interesting. One of my hopes is I can get this radio working well and then use this radio to help with another radio very, very similar to it, almost identical to it, that has low, I'm distracted by the alarm ringing. Low FM, but yeah, this one's got a low FM also. Maybe we'll try a different tube when I get back with a load of groceries. We'll try a 6BQ and see what happens. Interesting stuff. Okay, so I was lamenting about sometimes how little I seem to know when I look on the internet and read what people are talking about. It's very intimidating, in fact. But on the other hand, you can flip that around and say, here's an opportunity to get more under my belt about all this stuff. And it turns out there's a whole series of tubes that are kind of swappable. I didn't really realize that. Slightly different, but quite similar. 6BZ7 is so similar to a 6BQ7 that in some cases the tube has both numbers on it. So, and just exactly how similar these are to an ECC85 exactly. I don't know yet. My head is full of stuff. I thought what I should do is I should test this guy. It's apparently brand new. Well, I guess it can't be brand new, can it? So I've set the tube tester up for a 6BZ7. 6BZ7. Let's check it. EV 7608 7608 with a 9. This is the suppressor setting, and I think these tubes are triodes. So I'm not sure what's going on with that. And that's what we need to do. Let's plug it in. I have lots of these tubes. If they turn out to be workable, then that's great. If that's what happens. So I'm kind of hoping this tube tests weak, although it's highly unlikely it's going to test weak, because apparently it's never been used. Okay, do the short test here. Now these tubes often have shorts in them apparently, but it's more from the kind of circuits they're in that are applying voltages in such a way that a short is more likely to develop. I guess that's the best way to put it. Especially in televisions. These were used a lot in televisions. Okay, 7608, 7608 with a 9 for some reason. And here we go. Wow! What's it supposed to be? I should have checked this. It should be 3150 to get rid of it, 5000 if it's good. So 5000 is going to be up here, and to get rid of it, 3150, just past the halfway mark there. Yeah, so it seems to be testing good. Now there's a two-part tube, of course. Let's do the other part. 2 tubes in one. 2103 with a 9. 2103 with a 9. Everything else stays the same. Well, how do you like that? It's not. That's odd, isn't it? It's pretty odd to me that one half would test higher than the other half. The two of them have been traveling together in an evacuated glass globe. How does that happen? That might mean that this isn't actually brand new, that this has been in use. So it's pretty clean. Okay, I got a whole bunch of these. Let's see if I can find a strong one. We should do a 6BQ. Let's do this. Look at my settings here for a 6BQ7. How different are they from the settings that are there now? So it's 7608. Sorry. Did I make a mistake? What's going on? BQ7. 7608. 6BQZ, completely different settings. What have I done here? 2103. So I've done the second test. Oh, I did the second test. What am I talking about? Oh my gosh. A little excited here. Something has happened that has got me quite excited. So here we are. Okay, second test. 2103 with a 0. 2103 with a 0. 13 and 88. So this is a 18 and 88. So a little different in the bias setting on the tube tester. And the readings are a little bit higher here in numbers. I'm going to dig out a 6BQ7. Try that in the radio. See what happens. Okay, before I try another tube, I've stuck the BZ7 back in here, and I've taken the suppressor setting and put it on 0. So this is a 9-pin tube, and the suppressor has 10 settings. Now 1, 2, 3, 4, 5, 6, 7, 10. I wonder what setting 9 is on here. So we're going to try it with a 0 and see what kind of horror story could happen with that. It's about the same, wasn't it? Let's try it again. So we're really close to the center here. It's exactly the same. Don't know what's going on in the tube tester with setting number 9. I never really noticed that there's actually 10 settings for a 9-pin tube. Okay, I'm going to get myself a 6BQ7. Well, I must be smarter than I realize. 6BQ7, 6BZ7, all in the same bag. By the way, storing tubes in a bag like this, not the best idea, because the tubes are bumping around on each other and they start erasing the numbers off. So you gotta be careful if you're gonna put them in a bag like this, or have them loose in a box. Same sort of thing. So shame on me, but space is the issue. Right? I just don't have the space to. So I grabbed one here. It says 6BQ7, 6BZ7. That shows you how similar these tubes are. Let's go in. Now that's a loose tube, not in a box, but let's just see how it tests for fun, and then I will probably carry on hunting down one that tests really high to put in the radio. So shorts, not a very good response on the short light. Yeah, there's a bad. What's this? Here we go again. Let's try that again. A little better flash on there. Still warming up. I don't think it's going to get too high though. On the scale here. Okay, I'm going to have to hunt through these tubes and see what I end up with. Looks like another bag. There's another bag. 6BZ. Oh, that's a 6. 6BZ6. Okay, lots of fun doing tube testing. See if I can find a really strong one. Put it in the radio, but I'm really quite suspicious. The radio's weakness is coming from the output tube, but I don't know. So I'm continuing my investigation into the tubes, and I got another idea here. Since one of the issues with this receiver is its low output, what about the output tube? What can I tell about it? I can't put it in a tester. I don't have a tester that will test that tube. What can I tell? Now here's another tube, not from that radio, but as an example. You can see all the dark stuff built up in it. It's material on the inside of the glass, it's not on the outside. seems to be related to the hole in the plate here, as if something is coming through. Maybe coming through and striking the glass and sticking to it. What would that be exactly? You know, I don't know. I'm sure somebody knows exactly what that material is. There can be materials in a tube like this which are, what's the right word, volatilizing, turning into a gas, and then perhaps under electric force being projected onto the glass here. I don't know. But this is a sure sign of high mileage, maybe even hot operation. This is an output tube here. I think this is a 50C5, something like that. Now let's look at the actual tube in the radio and see what we can see in it. So there are a couple of interesting signs here. One of the ones that jumps out at me right away is what's going on the top. I can see through it. Now usually a tube like this has a reflective coating on the inside that has come from the blasting of the getter. If you look, you can see the getter ring in there. Inside there's a ring inside where my thumb is kind of pointing there. And that contains a little chemical that during the manufacture of the tube is used to produce an active chemical coating on the inside of the tube called the getter. You see this on most every tube. Let me just grab any other one. So just another tube. You can see the shiny metal coating, but this one, not really at all. In fact, I don't think I've ever seen a tube quite like that. What happened to the getter? The getter got up and gone. Now here's another interesting thing here. I'm not sure what to make of this. When you look at this tube, see they have the brand name here, Lorenz, but the upper half of the branding is gone. And if you look in the tube, you can see that the plate structures end right there. That's very curious to me. Now either it was made like this, which I doubt. I don't think Lorenz wanted half their brand name missing on their tube, or it's been burned off in some fashion that I don't know anything about. The last thing is, when you look at these holes in the plate, you can see a dark material, similar to what I was showing on the inside of the glass. In fact, I think it's hard to see here, but I think there is some on the inside of the glass, and then some is right on the outside of the plate, as if something's come through that hole and then zoom, got stuck on the plate. Like the sound effect there? These are all signs that this tube is bad. Worn out, maybe overheated, maybe even has gas in it. But typically, I don't know if I have one here, when a tube gets gas in it, let me just look quickly. I tend to keep examples of this stuff laying around, but I don't see them now. Whoops. Just banged my microphone there. Air gets into the tube. The getter usually turns white. It's quite dramatic. It's quite obvious that there's something funny about it. I guess I've thrown all my broken tubes out here, so I don't have a good example. But it's very obvious. Snow-capped tube. Sometimes the getter's on the side of the tube. Same sort of thing can happen. Sometimes the pieces of the getter will come away from the inside of the tube, and you'll find them in the bottom. And you can shake the tube around and hear these bits and pieces falling around. So those are all indications that this tube is worn out, and that couples with the low output from the receiver. Even if the earlier tubes in the radio are not working properly or working somewhat weakly, turning the volume right up to hear anything is a little bit unusual. I think this tube is shot. This is a bit of a rare tube, ECC85 probably made very late in the tube manufacturing game, just when the game was coming to a close, because transistors were beating them up. And getting another one of these maybe could be difficult, but in fact I've already got a friend of mine who's got a brand new one. So we could just get a hold of that brand new one, stick it in the radio and see what happens, and that would pretty much settle the issue. So that's the story there. for this radio at this point sure looks like, again, a whole pile of tubes worn out in here. It seems so strange to me. Okay, so the tray full of tubes you see here, these are all 6 BQ7s or 6 BZ7s. And I've tested all of them. I did it in a emissions tester, but a fairly high quality emissions tester. So that gives a pretty good way to compare the results between all these tubes. Now there's 3 more of them here, and they're in my hand because all 3 of these showed a cathode short, cathode to heater short. And apparently, from what I read on the internet, that's a common thing in these tubes. Not because of the tubes themselves, but because of the way they're operated, mostly in television sets. So 3 guys for the dumper. Might be interesting to stick one of these inside this other tester and test it. That might be interesting. So here's the results. I wrote them down. If the numbers got high, I tested both sides of the tube. So you can see there's a 85 and 72. These numbers in themselves don't really mean anything. Just the higher the number, the better the emissivity in the tube. 79, 104, 82, 85, 83, 92, 193. This is the winner. That's tube number 16. He's the winner. So now we're going to try the winner. Let's try a winner. And the one right before it is a big loser. We'll try this one and this one in this tube tester, and then we'll stick these in and see if the short is detected. Why not? I like this kind of stuff. I like to kind of reassure myself that things really work the way they are supposed to work. Would that include me? And this is a 2-part tube. We'll probably only test one part of the tube. Okay, let's go with the bad one first. I'll stick it in here. This is set up for a 6 BQ7, right? Right, Jim? Let's just make absolutely sure I haven't lost my mind. So this is 21030. Yeah, okay, that's one half of this tube here. Stick them in. So 50% on that tester is a failure, is a bad failure. 50, the number 50 is a bad failure. So let's see if this comes up. I'll put these ones here. These are the ones that reported a short. Here we go. Looking for a short in here. Just watching the short light. All is clear. Okay, expectation for this tube, 6BQ7, second test, at least 3,340. So 3,300 would be just past the halfway mark. That's what you get. Now we're going to pull this one out, mix them up, put in the good guy. This is the guy we're going to try in the radio, I'm pretty sure. Put him in. The reason it's common for a short to be in these tubes, according to what I read, was often they're used in a cascade sort of arrangement where one half of the tube is kind of like the preamp for the other half, and I probably got this wrong. Something on one half is connected directly to the plate of the other half. So the cathode of one side is connected to the plate of the other side. That drives the cathode voltage up to the plate voltage, and then that strains the tube and breaks down whatever it's not insulation, right? It's just spacing inside there. Maybe a little arc occurs and then the thing gets welded. I don't know. Here we go. This guy here. This is our wonder tube. I wonder if it's going to fix the radio. What do we get for this? Well, look at that. The other thing I noticed about this tube, can you see how much it's glowing? It's just glowing like a son of a gun. Like it's got a little extra heat in it. May be the case. Why did it just dull right down? Because I broke the connection here by moving it. So this is the guy we're going to actually test out. Now for fun, let's stick some shorted tubes in here. So the short test has numbers, 1, 2, 3, 4, 5, and I think if you looked in the manual you could find out that a short on 5 is a certain kind of short. So keep your eye on the short light. Oh, this guy says he's fine. It'll make you wonder. But it's in the it's bad because it's supposed to come up to 30. What was it? 3,300, which was way up here. So it's approaching the halfway mark here, which is pretty bad. But no short showing. That's curious. Is my tube tester not working? Is there short of a sort that won't show here? Seems kind of odd to me. Okay, this one here we go. No short. Same sort of reading. Wow. The other tube tester is also a neon light indicator type. Short indicator. Does this mean to say my tube tester is failing to detect the short? It's really kind of a crummy switch. What do you think of that? So of course I didn't test this, and this one's also quite bright. I didn't test this one because it showed a short. Now I'm going to bring the other tube tester in here and we're going to repeat this. Because look at that. That's the best tube going. Except there's a short. Supposedly. Let's test the tube tester. Okay, we're going to test the tester. So this is an emissions tester. It's a dynamic tube tester, but I'm pretty sure it's an emissions tester, but of a high quality. I think this is a well-known tube tester. I like it a lot. It's very fast. It's very simple to use. So I have a 6. The way it works is you just set these buttons here, and it gives you the buttons down here, like A, 1, 2, 3, 7. So A, 1, 2, 3, 7. And then A, 45, A, 45, that's it. Stick the tube in. Give it a moment. This, I think I've picked the one that I actually ran the test on, the other tube tester. Okay, so over here in the short test, it shows you KP, G2, G1. So cathode, plate, grid 2, grid 1. Okay, and this is the indicator light. Here we go. But bingo, it's on. You having some trouble seeing it? It is on. Still having trouble seeing it? So one of these lights. There we are. Now you can see it a lot better. It is on. So I would not continue the test with that, like that. Oh, there's another one showing down here. Grid 1. I didn't even get that far last time. So, one tester, this tube looked fantastic. The other tester, it should be in the garbage. Wow. Wow. Okay, let's do these other two. And I'm pretty sure they're going to show a short. It's the same machine again. This machine has the ability to read the resistance of the short by turning this control until the light goes out. The light never goes out, so it's a hard short. I think that's how you do it. Did the G1 do it too? No. Ooh, what was that? Something clicked. I don't like that. Shorted tubes in your tube tester, not the best thing. This one goes in. We're going to need a tiebreaker. It's not really a tie, is it? There's the short. Nothing on the grid. Okay. I won't push the test button for these. I think we need a tiebreaker tube tester. I'll put these over aside. And I'll fetch another tube tester. Okay, so with this tester, the shorts are read differently. They're read right off the scale, and there's actually a resistance reading. You can actually read the resistance of the short. Let's start with the good tube. See what this one tells us about the good tube. How good is the good tube? Again, it's a two-part tube. We'll just test one part. See, it's very bright. Very bright. And if that means it's hot, it's hotter. Why so different? I mean, it's glowing like a son of a gun. You practically light the room from that. Here we go. So we're watching the meter now, and we're looking for it to pop right up if there was a short. No short. Ready to perform the test. 6BQ should come. 1380 is the reject point. 13, right around here. Way over. What is this tube for sure? What is 6BQ7? 6BZ7. Made in Canada. Oh, that's why it's so good. It's made in Canada. Okay. Getting a real kick out of this, can you tell? Okay, now we pull up our three shorters. The color, the amount of heat determines the color of the color temperature, I guess you might want to call it. Maybe that's not a good phrase. But you know, the deeper red, the cooler it is, the less electrons it's going to emit. Well, this one's glowing pretty good too. Okay, we do the test. Ta-da! There it is. It's come up just a little bit. It says 5 megohms. And slowly going down. I think I saw this before. A low reading on a tube, like a low short reading, and then it slowly goes down. Probably maybe as the elements are heating up and expanding. You know, that weird thing that I mentioned before. It's like a magnetoconstriction. As a secret physical occurrence, secret during the Second World War, it was discovered that a magnetic field in a piece of metal causes the metal to shrink ever so little. Magnetoconstriction. And they used this factor in a top-of-the-line military radio back in the day to create a filter with almost a square response. I have that radio. There we go. And it does have a excellent filter. There's nothing showing up here. That's actually going down a bit. I mean, you can hardly see it. I can see it, but you'll never see it on the camera. But this guy would pass. Oh, this is really strange. Who to believe? You have like 10 tube testers going in here eventually. No, I don't have 10 tube testers. Yeah, this one's glowing pretty good too. Maybe it's just because I have the lights down low. It's kind of like a romantic environment for tube testing. There we go. Oh, different setting. Okay, so that's number 5, and I have the manual handy here. We can read quickly what a short on test number 5 means. Test number 5. For a little table in here. There it is. Leakage test, switch position. Number 5, control grid and all other elements. So it's looking for a short between the control grid and the rest of the stuff in there. Yet the other tester said the fault was on the cathode. This is why you should only have one tube tester, and that's it. I don't think I'm going to push the test button because I really don't want to damage my tube testers. This is hot. This got hot that fast. Could it be that the short is conducting some current and the heater is actually running with more current in it than it's intended to? I don't know. I have so many of these tubes, I can certainly afford to lay these ones aside. And now we are going to take that really good tube, stick it in this radio, and see if it works any better. Here it is. This is the best baby going. I would be really happy if this kind of tube works here, because almost all these German radios have the same tube here, ECC85. And I don't know how many there are around in the world, but there sure are a lot of these 6BQ and 6BZ7s. Okay, everything ready? Am I too excited to do this? Should I take a break? No. Fire one. Volume's right down. Magic eye has come on. We're switched to FM. Antenna's plugged in. Tube is going like crazy here. Look at that. It's kind of a yellowy orange glow instead of a darker reddish orange glow. And here's another one that's really glowing down here. This guy here. Okay, up on the volume. Definitely more volume, I'd say. And on the tuning. Well, we got somewhere. That's the end of the line. It's full volume. The Magic Eye is not responding here at all. That's kind of... What's happening there? I thought it was responding before. Where's it going? It's leaving us. What? Is that my light? No. Don't know what that is. And silence. So this is the low frequency end here, and this is the high frequency end. So this is 90, this is 108. I don't know what to say, but that's insufficient volume considering it's up full. That should be just blasting our ears off, really. This is where it should be, down here. You have it down here, there's nothing. Can't hear a thing. So I think all indications are this tube has to be changed out. To try another tube here to see if the volume kicks up. The quality of the reception, which wasn't all that great, it could be because of antenna direction again. It's got a dipole in here, it's got some directionality to it. But with it fading out as you go up band, I think that indicates something more is wrong. Could be alignment, just a little bit of alignment tweaking, and bingo, we'd be doing a lot better. Let's try the volume check on the broadcast band, because that basically just removes this part. This part is no longer working. This tube doesn't matter anymore. So if the problem here is in this box or weak tube or whatever, that's out of the picture. Find out about the rest of the radio by turning this up. Up and up and up and up and up. Seems like more volume. But this guy's got problems too here. What was that? Once again he asks. Okay, we're at the end of the road, so we're down here around 550. Let's turn the antenna this way. It can make a big difference. The null on these antennas can be very deep. Volume is almost up full. Ooh. I don't like that. And if we don't get any stations down here, we're not going to get anywhere. So that too can suggest alignment trouble. Can't imagine that the output tube can affect the radio part of this. How come this isn't doing anything again? What's the matter with you? I'm sure this was working one of the earlier tests. Let's jump in a bit. Gone again. Oh boy. Let's go back. Okay, so we're at the bottom, so we'll come up a bit, look for 590, be somewhere around here. Louder and quieter. Is that the button? Gosh, it's almost identical to the other radio in its behavior. Cracked solder joints. This tube's well, just fade out again. Oh my gosh, haven't we got a lot of problems here? It's one thing if a radio has one problem, multiple problems. Well, I'm going to guess it's a cracked joint, cracked solder underneath. This is not a happy radio. It's exhibiting all the same traits as the other one. Weak FM. The other one's output is good. If the crack is on the heater connection, if that's what it is, you can imagine the heater kind of half working at times, or imagine it heating up and then failing and cooling down, and you get this slow up and down drift. Okay, that's all for another time. I think what we're finding out here is multiple problems in the radio. Chance of cracked solder joints underneath. Excuse me. Tube is weak, but not so weak we can't work on the radio. Just need to turn the volume up. I think this tube is doing the job up here, but not completely sure. Radio fades out as you go up band. Could be alignment issues. Haven't changed really any capacitors except those ones that were cracked. Just 2. But it has a type of capacitor that I think is quite reliable here, but maybe I'm wrong. Okay, that's the story. It's not the best story. It's not what I was hoping for. I was hoping this would be a real snap. And I could then get the other similar radio in here, in between the two of them I could make progress. So anyway, well, thanks for watching. I'm done for today. It's actually late in the afternoon now, so I'm done for today. It's just thanks for watching. Oh, I'm too excited.